Skill 21, Congruence in Overlapping Triangles. In number 2, we're going to identify any common angles or sides in the triangles. So we're going to talk about triangle DEH, D to E to H, so that triangle. And then we are also going to be talking about triangle DFG. So DFG. So we want to find the common angles or sides. Okay, so when I'm looking at this, what I see in common is the fact that they both go through this D right here. Okay, so what I would say is that there would be a common angle at G, D, F, and angle H, D, E. So that would be an angle that is the same, so we could call them the same by the reflexive property. For number 6, we're going to separate and then redraw the indicated triangles, then identify any common sides or angles. So first I'm going to redraw it. PQS, well PQS is right here. So that's one of them. And then the other one is QPR. So Q over to P down to R. So I'm going to redraw those separated, and then I'm going to identify their commonalities. Okay, so the first one, I have PQS is right there, P, Q, and S. And then I have my other triangle QPR, and the thing that is in common is my PQ. Those are the same in both of them. So my common side would be side PQ is congruent to side PQ by the reflexive property. Number 13, we're going to prove that two sides are congruent. Given AB is perpendicular to segment BC, segment DC is perpendicular to segment BC, segment AC is congruent to segment DB, and angle A is congruent to angle D. That is given to us. We want to prove that segment AE is congruent to segment DE. So the first thing I'm going to do is mark things. So I already have the perpendiculars marked. Now I'm going to say that AC is congruent to DB. So I'm going to do that here. So right here and right there, the whole thing. Because they're overlapping, it's kind of hard to tell, but I know that those two are congruent. And then I'm also going to say that angle A is congruent to angle D. So I'm going to put the one mark in there. Now I'm going to look at what's in common between the two of them. And what I see is this segment BC is in both triangles here. So I'm going to say that BC is congruent to BC by the reflexive property. So that would look like segment BC is congruent to segment BC by the reflexive property. Okay, next I'm going to try to say that two triangles are congruent. So what I'm going to look at is I'm going to look at this triangle ABC. And I can see that there's an angle, and then a side, or angle, angle, side. Either way you want to look at it. And then we have D, C, and B, again, angle, angle, side. So I do have two congruent triangles. So I can say triangle ABC is congruent to triangle DCB, and that's by the angle, angle, side theorem. Okay, so now I can say a different side is also congruent. I can say that AB is the same as DC. And that's by corresponding parts. Segment AB is congruent to segment DC by corresponding parts of congruent triangles. Okay, now the next thing, I can look at a couple of angles. I can look at this angle right here and this angle right here. They are created by an X, which is vertical angles. So I can say something about those. So step 5, angle AEB is congruent to angle DEC by the vertical angles theorem. Okay, now, since I have an angle, another angle, and a side, I can say that these two triangles are congruent. So I say triangle AEB is congruent to triangle DEC by the angle-side theorem. Well, finally, we should be able to say what we want to say, because our goal was to say that AE was the same as DE. Well, now we have these two triangles being the same. So since those two triangles are the same, the two corresponding sides should be the same. So I'm going to say segment AE is congruent to segment DE by corresponding parts of congruent triangles. And then I'm done with my proof. For number 17, segment AD is congruent to segment ED, and D is the midpoint of BF, and that is given. So we want to show that triangle ADC is congruent to triangle EDG. In order to do this, we have to use what we know. So we actually know a couple of things about some different sides. So we know the side that's already marked, and I also see that the D is the midpoint of BF, so that cuts those evenly. So I can say that next. So I'm going to say segment BD is congruent to segment FD by definition of midpoint. Okay, so now I know two things if I look at the triangles EFD and ABD. So I can go somewhere with that and see if I can say something about an angle. So if I look at this angle right here, this angle right here, those are vertical angles because they are created by the X. So that is going to be when I say they are congruent. So I say angle ADB is congruent to angle EDF by the vertical angles theorem. Well, now I have a side, an angle, another side, so I can say that those two triangles are congruent. So I'm going to say that this triangle and this triangle are congruent to each other. The triangle ADB is congruent to triangle EDF by the side angle side postulate. Well, if I know that's the case, then I can go further about other parts and other angles. So I can say that angle E right here is the same as angle A right over here. And that's because they're corresponding angles in their given triangles. Angle A is congruent to angle E by corresponding parts of congruent triangles. Okay, now the next part I can say is I can say that ADC, that angle, ADC right here, is the same as EDG right here, because again, they're created by the X, so it makes vertical angles. So angle ADC is congruent to angle EDG by the vertical angles theorem. And finally, since we have an angle, a side, and another angle, we have congruent triangles. So I have triangle ADC is congruent to triangle EDG by the angle side angle postulate. For 19, we have QT is perpendicular to PR, QT bisects PR, and QT bisects angle VQS. So I want to show that VQ is the same as QS. So I might have to show that a couple triangles are congruent in order to do this. So I'm going to start by something easy, something that I can tell right off the bat is the same for multiple things. This QT is the same as QT, and it is parts of multiple triangles. So I'm going to start with that. That might help. So I'm going to say QT is congruent to QT by the reflexive property. Okay, now where I'm going to go from here is I have an angle and I have a side, so if I can get another side, I can have side angle side. So that's what I'm going to kind of go for. I have not used this segment bisector yet, so that's where I'm going to go next. I'm going to look at the fact that QT bisects PR, making this the same as this right there. So I'm going to say PQ is congruent to RQ by the definition of segment bisector. So now I have an angle in the middle and then two sides. But before I can do that, I have to say that right angles are the same, because I have a right angle here, which was given, and since it's perpendicular, there's a right angle there. So I know all of that stuff, but if I only knew they were congruent to each other, then I could say the next step. So I can say that angle PQT is congruent to angle RQT by the congruence of right angles theorem. Well, now I have side angle side, so I can say two triangles are congruent. So triangle PQT is congruent to triangle RQT by the side angle side postulate. Okay, but that's not quite getting me all the way where I want to go yet. So now I need to look at another bit of information that I haven't yet used. So what I'm going to look at now is the fact that QT right here bisects VQS. VQS is right there, and this is a bisector, so I know that this angle right here is the same as this angle right here. So I can say that now. I'm going to say angle VQT is congruent to angle SQT by the definition of angle bisector. Okay, now the next step might be a little bit trickier to see, but if we remember that we have already proved these two triangles are congruent to each other, then that means that all the corresponding parts are also congruent to each other. So I can say something about another angle, this angle right here. Those two are corresponding, so they're congruent to each other. So angle QTP is congruent to angle QTR by corresponding parts of congruent triangles. Because I have an angle, a side, and another angle, and then an angle, a side, and then another angle, I have angle side angle, which makes congruent triangles. Triangle VQT is congruent to triangle SQT by the angle side angle postulate. And finally, now that I have those two smaller triangles congruent to each other, I should be able to say that all those corresponding parts, including that one right there and that one right there, are congruent to each other. So to finish our proof, we're going to say segment BQ is congruent to segment SQ by corresponding parts of congruent triangles. That's it for your notes over Skill 21, Congruence in Overlapping Triangles. Summarize your notes, make sure these problems make sense, and then finish the rest of this worksheet, and you should be ready for your quiz.